Before we can delve into the fascinating world of video technology, it's essential to understand its roots in photography and film. These two mediums, though distinct in their own right, share a common ancestry and have evolved together over the centuries. Both photography and film grapple with the fundamental challenge of capturing and preserving visual information. This challenge has driven countless inventors and artists to push the boundaries of what is possible. Early pioneers, driven by a thirst to freeze time, experimented with light-sensitive materials and camera obscura techniques. The camera obscura, a simple device that projects an image of its surroundings onto a screen, was a crucial stepping stone in the development of photography. These efforts culminated in the invention of photography in the 1800s. The ability to capture a moment in time and preserve it for future generations was nothing short of revolutionary. Niels van Niepce and Louis Daguerre are credited with developing the first successful photographic processes. Niepce's heliography and Daguerre's daguerreotype were groundbreaking in their ability to produce permanent images. Their inventions allowed for the creation of permanent images, a revolutionary concept at the time. The daguerreotype in particular became immensely popular and was widely used for portrait photography. Simultaneously, inventors were striving to capture motion. The idea of recording and replaying movement fascinated many, and numerous experiments were conducted to achieve this goal. Eadweard Muybridge's groundbreaking work with chronophotography in the late 1800s paved the way for moving pictures. Muybridge's experiments involved capturing sequences of images that, when viewed in rapid succession, created the illusion of motion. By rapidly sequencing images of a horse in motion, Muybridge proved that moving objects could be captured and displayed with startling realism. His work was a significant milestone in the journey towards the development of film. These early photographic and cinematic innovations laid the groundwork for video technology. The ability to capture and reproduce both still and moving images opened up new possibilities for storytelling and communication. They demonstrated the possibility of not only capturing still images but also recording and recreating the illusion of movement. This dual capability would eventually lead to the creation of the first motion pictures and later, the development of video technology as we know it today. The early film screenings captivated audiences who were amazed by the lifelike motion and the ability to see events unfold before their eyes. This new medium quickly gained popularity and set the stage for the future of visual entertainment. As film technology advanced, so did the techniques and tools used by filmmakers. Early film studios began to emerge, and filmmakers experimented with different methods of storytelling, editing, and special effects. The introduction of color and sound further revolutionized the film industry, adding new dimensions to the viewing experience. These innovations paved the way for the rich, immersive films we enjoy today. From the humble beginnings of photography and early film experiments, we have come a long way. Modern digital cameras and advanced film production techniques have transformed the way we capture and share visual stories. Today, video technology is an integral part of our lives. From digital video editing to streaming platforms that allow us to watch content from anywhere in the world. The journey from the dawn of photography and film to the digital age has been a remarkable one, filled with innovation and creativity. As we continue to explore the world of video technology, it's important to remember and appreciate the pioneers who laid the foundation for this incredible medium. Their contributions have shaped the way we see and experience the world around us. While photography and film excelled at capturing visual information, a new challenge emerged: how to transmit these images over distances. This question marked the birth of electronic imaging and the pursuit of television. The core hurdle lay in converting visual data, light, shadow, and color, into a format that could travel through wires. This required a fundamental shift from chemical and mechanical processes to the realm of electronics. Scientists and inventors recognized the potential of electricity to carry information rapidly. The invention of the telegraph in the mid-1800s demonstrated this capability. However, transmitting static text was one thing. Sending dynamic images posed a far greater challenge. The solution lay in finding a way to dissect an image into discrete electrical signals. These signals could then be transmitted and reassembled at the receiving end, effectively reconstructing the image. This concept, known as image scanning, became the cornerstone of early video technology. The story of video technology is incomplete without acknowledging the contributions of Alexander Bain, a Scottish inventor. Bain's work in the mid-19th century laid the foundation for many of the technologies we take for granted today. His innovative spirit and relentless pursuit of knowledge were instrumental in shaping the future of communication. While not directly responsible for television, Bain's invention of the electric telegraph in 1843 played a pivotal role in its development. This groundbreaking invention allowed for the transmission of information over long distances, revolutionizing the way people communicated. The electric telegraph was a marvel of its time, enabling messages to be sent and received almost instantaneously, a feat that was previously unimaginable. My ingenious device utilized a scanning system to transmit images over telegraph wires. This was a significant leap forward in the field of communication technology. The scanning system was a complex mechanism that required precise engineering and a deep understanding of electrical principles. I employed a pendulum to scan a metal image, line by line. The pendulum's steady rhythmic motion was key to the scanning process, ensuring that each line of the image was accurately captured and transmitted. This method was both innovative and effective, demonstrating the potential of electrical transmission for image replication. The varying electrical resistance of the image was then converted into electrical pulses, transmitted, and used to reconstruct a crude facsimile at the receiver. This process was a precursor to modern fax machines and laid the groundwork for future advancements in image transmission technology. Though rudimentary by today's standards, Bain's fax machine, patented in 1843, demonstrated the feasibility of transmitting images electrically. This invention was a significant milestone in the history of communication, showcasing the potential of electrical signals to carry complex information. His work established a crucial link between visual information and electrical signals. This connection was essential for the development of future technologies that would eventually lead to the creation of television and other forms of visual media. It laid the groundwork for future inventors to refine and build upon. Bain's pioneering efforts inspired a generation of inventors and engineers to explore the possibilities of electrical communication, leading to a wave of innovation that transformed the world. While Bain's invention focused on replicating static images, it planted the seeds for the development of technologies capable of transmitting moving pictures. The principles he established were later adapted and expanded upon by other inventors, paving the way for the creation of motion picture technology. His work serves as a testament to the interconnected nature of scientific advancements. The progress made in one field often influences and accelerates developments in others, creating a web of innovation that drives human progress forward. Bain's contributions are a perfect example of how one inventor's vision can have a lasting impact on the world. Building on the foundation laid by Bain and others, a German inventor named Paul Nipkow made a significant leap forward in the quest for television. Nipkow's work was driven by a vision of transmitting images over distances, a concept that was revolutionary for his time. His innovative approach laid the groundwork for future advancements in the field of television technology. In 1884, he patented a device called the electric telescope, which utilized a unique mechanical scanning system. This invention was a breakthrough, as it introduced a method to systematically scan an image and convert it into electrical signals. Nipkow's electric telescope was a precursor to modern television cameras, and it represented a significant technological advancement.
At the heart of my invention was a rotating disc perforated with a spiral pattern of holes. This disc, now known as the Nipkow disc, was a simple yet ingenious solution to the problem of image scanning. The spiral pattern allowed for a sequential scanning of the image, line by line, which was essential for creating a coherent electrical representation of the visual information. As the disc spun, each hole scanned a narrow line of the scene being imaged. This mechanical scanning process was a critical step in converting visual information into electrical signals. The precision of the disc's rotation and the alignment of the holes were crucial for accurate image transmission. Light passing through the hole struck a light-sensitive selenium cell, generating an electrical signal proportional to the brightness of that specific point. The selenium cell was an early form of a photoelectric sensor, and it played a vital role in the conversion process. The varying intensity of the light hitting the cell created a corresponding variation in the electrical signal, which was essential for representing the different shades and details of the image.
This process was repeated as each subsequent hole scanned the next line of the image. The continuous rotation of the disc ensured that the entire image was scanned in a systematic manner. This repetitive scanning process was fundamental to the creation of a complete electrical representation of the visual scene. The resulting stream of electrical signals, fluctuating in intensity, represented the complete image. These electrical signals could then be transmitted over a distance, allowing the image to be reconstructed at a remote location. The concept of converting an image into a series of electrical signals was a groundbreaking idea that paved the way for modern television technology. At the receiving end, a similar disc rotating in sync with the transmitter reconstructed the image, albeit in a crude and flickering form. The synchronization of the transmitting and receiving discs was a critical aspect of the system, as any misalignment would result in a distorted image. Despite the challenges, this method demonstrated the feasibility of transmitting visual information over distances. Nipkow's disc, while mechanically ingenious, suffered from limitations. The mechanical nature of the system imposed constraints on the resolution and quality of the transmitted image. Additionally, the reliance on precise synchronization made the system prone to errors and inconsistencies. The image quality was poor, and the system relied on synchronization between the transmitting and receiving discs, which proved challenging. The flickering and low resolution of the images were significant drawbacks, but they were also indicative of the early stage of television technology. These limitations highlighted the need for further innovation and improvement in the field. Nevertheless, Nipkow's invention marked a crucial step in the evolution of video technology, demonstrating a practical method for image scanning and transmission. His work inspired future inventors and researchers to build upon his ideas, leading to the development of more advanced and sophisticated television systems. Nipkow's legacy is a testament to the power of innovation and the relentless pursuit of progress in the field of technology.